As part of the IT Honors module, we were tasked with making a piece of furniture that only used standardized parts and uses exclusively 3D printed connections. Here you can see our design, a coffee table. The interesting aspects of this design are that we have a glass or partly glass tabletop, that all of the tubes are loaded with compression, that tubes intersect in multiple center points, and that seemingly thin tubes carry the entire table. We modeled our first iteration of the connections and 3D printed a whole lot of test samples to work out exactly what infill percentage, layer height, wall thickness, and tolerances were needed. After this, we were almost ready to make our first prototype. Seeing as though glass plates are generally really expensive, we were lucky to find a glass plate on Marktplaats, with almost the perfect dimensions as well. Now all that remained was to drill 4 holes in the glass for the legs to connect to the tabletop. For this, we of course contacted a specialist. We brought the glass plate to the specialist, and he used a special drill to make the holes for us. That went a little something like this. For our prototype, we had to think of something else. We really wanted to test whether the construction was even feasible, therefore buying an expensive new glass plate wasn't desirable. Therefore we decided that to prototype the table, we would use wood. And once we are confident enough about the rigidity of the construction, we could switch to the glass again. Therefore, we decided to build the space frame construction to see whether 1. It was strong enough to support any amount of force, and 2. Whether the tolerances would even allow building it. We printed all the parts. For the material we used PETG because it's less brittle than PLA. And we cut the tubes. We used steel because it needed to support a substantial amount of force, and keeping the tube straight while putting on force was really important to the aesthetic of the table. Then we started building. It seemed to go well. We had way more wiggle room than we initially thought, the parts fit snugly, and we calculated and cut the lengths correctly, until one of the parts snapped in the middle. The reason for this was because the connection was very thin, it had no fillets, and the print direction caused the layers to just split apart. So then, the parts were... We added thicker midsections with fillets, and changed the print direction. Furthermore, we slanted the connections to make them more flush with the tubes. With this final step, we were ready to assemble the final prototype. We had no idea whether it was going to snap in half again, but we were confident the connections were much better this time. Thank you to everyone who helped us in our process, and thank you for watching.